This video's kind of been a while in the making. I filmed a couple portions of it months ago, but this is basically going to cover my modifications to Ivan's original plans on the CNC router table. So in the description I'll put a link to his plans and a link to his original build videos. Something you definitely need to do if you buy these plans, just jump on his Discord server. There's a lot of good information, a lot of guys building these, and most questions you have with it could be answered there. To start off here, I'm going to start off with the way I store it. I don't have a lot of, I got a lot of shop room I guess, but I don't have a lot of wall space, and I didn't want this out in the middle of nowhere. So, got a lot of ceiling space though, so I wanted to install it on the ceiling and have it set up where I can let it down. I got a tractor project going, and I'm storing parts of that on the ceiling too, so got plenty of ceiling space. So we'll go with that. So I'll kind of describe how this works and get you some video of the top half and go from there. Something I want to make note of here is I have a couple safety chains, one on each side, just in case these cables give way or the mechanism gives way. I don't want it falling to the ground or falling on top of me. I got one of these on each side. Once you let it down, I have just a key fob here. And it comes down. A couple things I'll show you close up here. I have 3 attachment points, 2 on this back side, then 1 over here. My limit switch for the lifting, I actually have not wired yet. It's all still a work in progress. But I have a couple snap action switches here in this spring-loaded assembly. And when you raise it, it clicks the switches. Let me raise it here to show you. Yep, so it's totally adjustable. I can loosen these and slide it wherever I want. Alright, now let's go upstairs in the attic and take a look. Alright, so a couple things to point out. I'm sure this is not up to any kind of building code, but when I attached this whole assembly here holding it, I didn't want to just pull on there, so I have a chain wrapped around it and a bolt and a turnbuckle going through to pull it tight. Also, I have not finalized my wiring. It's just there temporary for right now. Here's the controller I'm using for the remote. I still need to wire up the limit switches and mount all this. I don't keep this thing powered up when I'm not using it. I just plug it in, let it down, and then unplug it. Power supply I'm using is 24 volt power supply. The motor to run this is actually for positioning satellite dishes. I've had a bunch of these from a surplus store forever, probably 20 years now. The rollers I'm using is the cable roller off garage doors, bearing off garage doors. So I got 3 of those. The ones on the end go down through a piece of PVC pipe on each end, and then on the third one I have the roller in the middle. It's going off a couple of pulleys. Kind of dark down there, but then off another pulley and on that single piece of PVC that has a limit switch on it. So this is kind of rough in a couple areas here, but I definitely need to finish the wiring on it. But like I said, I don't leave it powered up. I don't trust to leave it powered up right now. Quick video of this thing doing its thing. That's down. That's up. let's go back downstairs. Most of these mods I'm going to point out here that aren't specific to my design, you should be able to get on the GitHub repository. Okay, at this point I'll do a walk around of the few things I've added. Alright, to start with, these verticals, I forget what the standard height is. I think in the plans it was 60 millimeters. I've bumped mine up to 8 millimeters. With 8 millimeter spacing here, it changes some of these. The power supply box is different than the ones on the plans. All that has in it is a power supply, and it doesn't have a cooling fan yet, but it will. It doesn't seem to get too hot as it is. We got our main power switch here. Then I have a separate box for controls. I'll put up screenshots of some of these parts in between. I guess I'll edit those in. On the box for the controls, there is a USB Mach 3 controller, so I'm running Mach 3 on this one. I have an indicator light for a 5-volt logic power supply. This comes from USB, and actually it comes from the USB hub right here because the computer doesn't have enough, won't handle enough current. Then there's 12-volt power to the motors. Then I got my e-stop. This light's going to flash if my e-stop's active. So, alright, so that's it for electronics. One thing with this USB Mach 3 controller, so I have options to have a pendant to move the stuff around. So I can manually move the carriage around with that. So that's kind of handy. We'll just continue around the outside. Obviously I mounted my PC to it, so that's a little different. If we go here on our belt tension, I use some springs to keep it tensioned. Pretty heavy springs. It seems to work. It doesn't, when I'm cutting, this doesn't move. So that should be pretty good. Yet to be determined. I've incorporated limit switches into my design. Limit switches themselves also have an LED to light up to show you they're tripped. I mounted these on the end stops, modified end stops. Moving on, same thing here. Limit switch mounted on a modified end stop. Couple things I changed to make it more rigid. I added a couple 3mm or 4mm, I can't remember. I think they're 3mm screws to help clamp it tight. So that's in addition to the 5mm center. The motor itself is the gear reduction version, except I decided to put my motor controllers on the back of the stepper motor and have forced cooling. Let me show you what that's all about here. Came over here where there's a little bit more light to give you some quick rundown on this. The motor controller boards I designed, there's similar boards available. I designed these boards to fit the DVR 8825 stepper drivers. Could also work with the A4988. But essentially, you have the drivers, some indicator LEDs and some capacitors. So this 2-pin connector over here is the power in, the 12-volt power to drive the motor. So we have 12 volts going to all the motors. That other connector, you have 5 volts in for the logic power. Then we got enable, step, direction, and ground. Those have their own signal wire. The top connector here is to the stepper motor itself. A1 and 2, B1 and 2. Got some LED indicators to help diagnosis if there's any issues. Basically status indicators. So this red one is motor power 12 volts. The green one is logic power 5 volts. Then we have step signal and direction signal. And the way the fans are set up, it pulls air through the heat sinks. So I have a heat sink on top and bottom. And it pulls air through there to keep it cool. And there's a connector on the end for the cooling fan. The way this mounts, sitting there just like this, mounted against the motor. So cooling fan on here, pulls air through, goes through the heat sinks, brings it out the back. Or it could be the other way around. I don't even remember now. It's been so long since I messed with it. I also got heat sinks on here. The Y motors don't seem to get too hot. The X-axis gets pretty hot because it is one motor doing the job. On the Y I have two. But still, it's not too bad. And I have the same motor controller on all of my axes. Okay, follow down here. Something I didn't point out earlier when we talked about the verticals. I made these brackets. I guess they're not brackets, or they're kind of guides, trim pieces, to help center the verticals and make it look better, but also hold them square. So that worked out pretty good. Something else to note too, all of my wires are hidden through here, and on some cases, like in this case, we got a 12-volt power rail running to the motors in here. There's a piece in here that I have capacitor bank built into it that's on the carriage itself to help supply power to the motor drivers. Alright, get here, we got another end stop, very similar. Now notice these are long, we got short versions to clear the clear the rail. And missing a plug. I ran out and still have not put them on. I ordered them, have them, but there's a couple bottom ones I haven't put in place. So I'll continue around. Before we start talking about the carriage here, let's talk about some of the bottom stuff. All right. So one thing I did to help support this cable track, you know, in the plans it's supported right here and it just hangs down. But I added a couple extras, put a flat piece of aluminum on it to help support it, keep it level, so it doesn't sag over time. Now another part of my electronics I didn't talk about earlier is this. There's a heat sink on this side. It's got a solid state relay in there. And Mach 3 actually controls your spindle. So I use Mach 3 to turn the spindle on and off. Unless I manually turn it on and off with the switch up there when I'm working on it. Something else I adapted here. Move on to the carriage. I wanted to be able to unbolt and remove the carriage if I needed to without having to remove all the wire. So in here we have two junction boxes. This back junction box is for control signals, so your step direction to whatever motor. And this junction box is power, 12 volts and 5 volts, split off this little one on top. So I can open it up here, separate it, and take the carriage off if I needed to. You'll notice limit switches for the Z. Now, I need to make the bottom one adjustable, obviously, because that's not, you'd have to have that adjustable for it to be accurate and work. So it's almost not used. Another spring here for spring tension on the X belt. Also, I have my router plug in up here with an extension cord running through this track, so I don't have to unwind the whole thing if I'm messing with the router or replacing it. So one of the mods we figured out on the group around the time I was designing this is to put our cable track here instead of having it stick out like it would in the plans. So in our X track, it's made this little bracket to mount onto the back, and it rides there nicely. Now if you notice, we still have the same motor controller on this one. Something else I designed, and I think now this is on the GitHub link, is these braces to go across and hold these bolts holding the idler bearings for the belt to keep it from spreading. I was going to make that aluminum, but once I printed it, it was pretty strong. I had issues with the bearings that it was spec'd for fitting, so I went with a smaller OD bearing and it seemed to work fine. pretty tight fit in there. You can see it really good on this one. Same thing there. Okay. Another on the back bar on the carriage, also use these, put these 2 extra screws to reinforce it. Now, here things get a little different in a couple areas. I accidentally ordered a 5-to-1 gear ratio motor when I was ordering one of these, and didn't want to waste the money, so I used it. Made an adapter plate to fit it here, so I don't have gear reduction on the belt for the Z lead screw. Alright, I think that's most of it. Oh, another thing that's very handy that's not in the plans, something I drew up when I was doing this, and I think it's on the GitHub file link also, is a jig you slide over this to center these rails when you go to drill the holes and bolt them down. And even if you drill the holes good, this could still be off center, so that have that jig tight against it when you're bolting it down, and it'll hold it straight. Okay. First up, power up. Hit our switch on our power strip, and now we see we have 5 volts power, but nothing else at the moment. We go to our motor drivers, we have 5 volts in all those too. Go ahead and get this computer booting while we're doing the other stuff. Now this main switch is going to give us 12 volts. Now we got 12 volt, we got 12 volt. And another mod I added I didn't talk about is a ring light. Let's see. Can't really get a good picture of that, but I'll throw a picture up here. That ring light is a halo for a headlight off of Amazon, 12 volts. And I 3D printed drew up and 3D printed a bracket to bolt it into. It's just got an extra 12 volt wire coming in here for it. Uh-oh, operating system checksum bad. What is that? I bet my BIOS battery's dead in this old 20-year-old computer. Okay, so we'll say it's set up, and maybe it'll actually work. Oh, F10, save and exit. Yes. Alright, well, hopefully that's booting up again. I'll show you a couple pieces of aluminum I'll cut just to give you an idea of the finish I get. It's not too bad. These are the end mills I'm using. And here's some wood pieces. Just cut some gears out playing around. That was the first cut ever with it. Also, I 3D printed a bunch of hold downs for this sheet metal I'm cutting. Whatever size metal I'm cutting, so I can bolt it down and hold it down well. Something I noticed too, now that I raise these verticals, if I have this carriage all the way down, it's more flexible. So if I'm cutting something thin, I'll throw up another board there to bring the work up, so this is more centered and stronger. Okay, let's open up Mach 3, see if we can make this move. I'm not going to actually cut anything out right now, just going to go over it. Okay. Yep, we're live. I'm just moving it with the arrows on the keyboard right now. It's slow, but strong. Okay. If we hit the E-stop, just going to trigger the e-stop in software, and it's going to want me to reset it, but it won't reset because the button's triggered. That light flashes when the e-stop's triggered, so now it'll let me reset. We're ready to go again. Show you the way these, I'm going to trigger the e-stop again, but these are our limit switches. They light up to tell me which one's tripped. I mean, it's obvious anyway because you can see which one's touching, but okay, reset this again. Let's try our pendant here. Turn it on. And then move it where we want. Move the Y. So I'll set this thing on low just to show you my indicator. So it's showing direction, or no direction, no pulse. We're just showing power. It's pretty bright, but the red is 12 volts, green is 5 volts. Now we're showing, we're going backwards. I'm going really slow here, so you're seeing a pulse. The LED all the way on the left is telling us direction. That's going to be negative Y. And if I go the other way, it's just the pulse. With that LED on the left off, it's telling me it's positive Y. So it's just a little bit of feedback to tell me what I'm losing if it's not working right. That's the x-axis. And with Mach 3, those of you that aren't familiar with it, it's some pretty standard CNC software. I actually built a CNC mill about 10-15 years ago, and I'm used to using Mach 3, so that's why I went with it on this. Changed the wiring scheme a lot, made it harder to wire, but it works pretty good. One more thing to show you here. We'll fire up the old spindle just to see if it works. Okay, so here's where I turn on the spindle, or it automatically turns on when I start cutting. My mic is noise canceling, so I don't know if it's going to cover that up or not, but it's running. Then I have another video in this playlist that's of me cutting a couple parts out. I know I have one cutting out the gears. I don't know if I have one cutting out any metal. We'll see, but if you want to see it work, you can watch that. But that's kind of my rundown and my modifications. I haven't used it as much as I'd like to, but it seems to work pretty good so far.